This design project investigates how a singular motion can trigger a chain of events within a network of joints. The outcome is the Nexus link system. The system uses a series of pivots and anchor points to multiply any singular motion introduced into the system. Tension is introduced when a user interacts with a pulling action. This tension then causes the components within the system to move, resulting in an overall form transformation. Upon release of the tension, the system moves to revert to its original state. We are all familiar with the gesture of pulling a string to turn on a light or a fan. It is instinctual, and I wanted to leverage that transferred affordance as part of the user interaction with the system. Gestalt principles of design were also used to guide the opening and closing of its form, with different visual cues such as transparency to showcase the object's functionality and the beauty behind its simple yet alluring mechanical principles. The electrical circuits were also thoroughly worked out and accompanied by an innovative connection point that works to turn on the lights when its form transformation is complete. Using everyday materials such as pins, rubber bands, paper clips, and nylon strings, I kickstarted my investigation into making links. I began exploring by creating a matrix of rubber bands held together by paper clips. By varying the way the paper clips are linked to the rubber bands and the direction of tension applied, I was able to create varying deformable forms due to the elastic nature of rubber. These configurations, though seemingly random, follow the same principle of nature, conforming to the path of least resistance. As such, when a new force is introduced to the system will naturally transform to best accommodate and distribute the tension amongst its joints to eventually reach a new equilibrium state, hence changing the overall form of the string matrix. By adding non-elastic and fixed elements into the matrix, I was able to better control and predict the dynamic movement that will take place when tension is introduced to the system. The main elements of the Nexus link system are its anchor points and the singular interaction direction, with ball bearings aiding to reduce frictional drag. All configurations of the Nexus link system have an open and closed state, with an overarching theme of convergence. In a singular motion, one can trigger a chain of events within a network of joints, which is also fully scalable by multiplying or combining different configurations to create forms of increasing complexity. And so this is the Nexus link system.